Sir Isaac Newton. Who was he? Was he a physicist, a mathematician, an astronomer, or maybe even a natural philosopher? How about all four? This man was, without a doubt, one of the greatest thinkers and innovators of all time. It would be difficult to choose one single thing that made Newton famous, for he is the reason for many significant things. But let's start with the beginning. Isaac Newton was born on 1642 Christmas Day in Woolsthorpe by Colsterworth, a small village. He was sickly and was not expected to survive, and his father had just died 3 months before Newton's birth. Newton's unfortunate beginning didn't stop him from succeeding, though. Isaac went to the King's School in Grantham, and in 1661, Cambridge University in England. He was just 19 when he began his scientific studies at school, and soon started studying the work of Aristotle, nature, and science. While a student at Cambridge, Newton soon found himself more interested in the teachings of other French philosophers like René Descartes and Pierre Gassendi, and started learning about particles and their interaction when he began his studies in math. In little more than a year, he had mastered algebra, geometry, and the use of algebraic techniques to solve problems of geometry. Newton soon began to develop new math techniques, including calculus, the study of motion, and without calculus, physics would not have been possible. Provided with his natural mathematical talent and his knowledge of the mechanical philosophers, Newton was destined for a most remarkable career in science. He was born during the Scientific Revolution, the movement that took place in the 16th and 17th centuries. During this time, scientists began to apply what is known as the scientific method, where they used observation and special tools to discover the laws of nature. Isaac Newton began to enhance the scientific method of the revolution and applied it to his 3 laws of motion and his law of gravitation.
What are these laws? Well, Newton's first law of motion is stated as, an object at rest stays at rest, and an object in motion stays in motion, with the same speed and the same direction, unless acted upon by an unbalanced force. For example, an apple stays at rest unless pushed by applied force, but will not move if that force is not used on the apple. Or, an apple will roll at a constant motion but will stop if a negative force is applied. Newton's second law of motion can be formally stated as the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object. This simply means if we were to drop both a volleyball and an apple, the apple would hit the ground first, because the smaller object's acceleration is greater. Newton's third law states that when an object exerts a force on a second object, the second object simultaneously exerts a force on the first object. This means the forces are equal in magnitude and opposite in direction. If we were to hold up an apple, the apple would be giving out the same amount of force to push the hand down as we would be giving to hold it up. But if the apple is thrown onto the ground, are the forces still equal? Yes. The force of the apple would be the same amount of force the ground would exert up. And lastly, there's Newton's law of gravitation, which is everything with a mass is attracted to everything else. This is just like when the apple fell on Newton's head. If an apple falls, it's going to go straight down to the ground, and gravity is causing this because the small object is attracted to a very large object, the Earth. There just happens to be another object in the way.